Murat Özbayoğlu, Chair of Artificial Intelligence Engineering at TOBB University of Economics and Technology in Turkey. Welcome to the Data Exchange podcast.
Thank you. Thanks.
So Murat, you and your collaborators have written two excellent survey papers on financial time series.
Yes.
Or time series in general, and the role of deep learning. So first off, why are you? So what's the interest? I can see the interest in time series because you're in your position is in a University of Economics and Technology. But when did your interest in machine learning, the role of machine learning, come into play?
It actually goes back all the way to my PhD study times. It was mid 90s when I was in US doing my PhD. At that time, artificial neural networks was becoming really hot again after like a cooling down period. So my advisor was working on that. So I was interested in pattern recognition in particular. So that seemed to be a good area to work on. So that's what I did. But my topic was totally different. It was fingerprint identification. It wasn't with time series but I mean, I was interested in time series, but didn't have the chance to work on at that time. And then later on, I worked in the industry, but just a regular software engineer in IT businesses. Then when I went back to academia, then I again went into these topics. So it was a long time ago, but the times that I really started working on those, I would say 2005, 2006, those times.
So at the risk of dating myself, in the late 1990s, I worked as a lead quant in a small hedge fund out here in California. And yeah. At that time, actually, I don't think we used the term machine learning much. We were using the term data mining, which a lot of the techniques that we were using fall under the bucket of machine learning these days. But yeah, I don't remember experimenting that much with neural networks. The things that we were playing around back then were support vector machines and
yes.
and those kinds of things. And but no, it's and what I found working in a hedge fund, which was my first job after I decided to leave academia, was how hard it is to actually apply these techniques and consistently make a profit.
That's right. It's
on the paper profits is one thing, but then when you put it out there in the wild, a lot of things that are so unpredictable. But I've had a long fascination with this the field of time series in general and finance in particular. So your papers, though, you folks decided to focus specifically on deep learning. And obviously, as listeners of this podcast know, deep learning is hugely impactful in areas like computer vision, speech, and more recently text. So, but these are areas that tend to be quote unquote unstructured data, right? So why did you decide to do a deep dive in deep learning for time series? Was it because you were noticing just a ton of papers?
Well, I always had an interest in financial time series. I was checking the machine learning models before, what they were doing. The most, notable problem was finding the proper features because you can call it time series, but it's probably the most chaotic time series or irregular time series that you can have, especially those price data. In regular time series, obviously you have some sort of seasonality trends, those type of stuff. But for financial time series, it's much more difficult to model anything into that. So It was a challenge, and like you said, I mean, it had high rewards. I mean, if you have a model that works well, then obviously you can use it in real world, and there were a lot of interest. So I basically, that was one of the reasons I said, well, okay, since I was working on machine learning, let me try to put that in a specific domain. Finance was, I mean, something that I was willing to work on. That's where it started. But then once deep learning came into the picture, we were thinking, well, then maybe it can handle the feature problem. The feature learning can take care of itself. So maybe it'll work. And then that's where we tried to start using those. And up to some point, yeah, I mean, it was doing better. But still, obviously, there are a lot of unknowns. Everybody is working on that. Everybody is trying to get the best model. But I mean, obviously, there is no such thing as the perfect model for anything. I mean, especially for that financial forecasting. But I think deep learning has some good opportunities to work on. So that's why people are preferring that.
And according to at least the papers that you've written, and I will link to both of them. The first one is called Financial Time Series Forecasting with Deep Learning, a systematic literature review from 2005 to 2019. So this paper is amazing because it has, you folks put together 13 tables, right? So
Yes.
that summarize all the papers that have been written that probe various areas of financial time series forecasting, which, by the way, Murat, for our listeners out there, I guess the two fundamental problems is basically predicting price and predicting trends, correct?
That's right. Yes, exactly.
Yeah. And then you and your collaborators went through basically the literature and organized them into these 13 tables, various kinds of tables. For example, commodity price forecasting, volatility forecasting, foreign exchange price forecasting, and so on. But so two quick questions. The first is in time series, especially financial time series, you don't have a lot of data. You don't have a lot of historical data, right?
That's right.
So the stereotype of deep learning is it's data hungry. So how can this possibly work, Murat?
Well, okay. One thing is, actually, you can have a lot of data if you want. Like, it depends what time frame you're working on. For example, if you're working on intraday data,
there's a lot of data.
Yeah, there is a lot of data. If you get the tick data, for example, you can have. But most of the time, you don't need probably that much data, just like you said. I mean, the problem itself seems to be, I mean, limited data. At that point, we are using deep learning models are used with a lot of data, mostly, but probably not necessarily. I mean, because the problems with early, let's say, machine learning models with deeper layers were the vanishing gradient mostly. I mean, where your excess layers were creating problems for the system to learn. But deep learning, since it has a lot of data, it was able to cover more, and also like techniques like dropout or some specific algorithmic, let's say, heuristics, you were able to overcome that problem. So in reality, I mean, even if you don't have a lot of data, you can still utilize those deep learning models somehow, and it'll give you some results. And we saw that. I mean, it was without overfitting, you were still able to provide some, put some models. And a lot of researchers, I guess, had the same thing, because there are so many papers in financial forecasting, in deep learning, and most of them don't use a lot of data. I mean, you can check their timeline. It's like 5 years data they have, or maybe 6, 10. I mean, there are papers which go.
So, Murat, generally, who are the people writing papers about financial time series using deep learning and machine learning? Are they from the computer science department? They're from the econ department. So where do these people meet? What conferences do they go to?
Well, these are application type papers. So most of the time, for example, you don't see them in ICLR or conferences like that. But for example, I have seen in a variety of like IEEE conferences, like
But these
computational
are they computer scientists or econ people?
Mostly, yes, mostly
Okay.
computer scientists, but they collaborate with people from statistics, economics, finance. But I would think that it's not, I mean, the real theoretical finance people don't like too much about applying deep learning or machine learning into, I mean, because most of the time they have, let's say, model-driven results. I mean, they have like the financial model and they apply data to that. I mean, since computer scientists mostly go the other way, have the data and then try to fit a model created by the like deep learning algorithm. So it's not easy to convince the theorists that it actually gives them a result, I mean, or a proper answer. So that's why most people that are dealing with those are computer scientists and data science, let's say, experts.
So in other areas where deep learning took off, let's say computer vision, speech,
Yeah.
machine translation, text, the community had well-established benchmarks. So the most famous one in, for example, in vision is ImageNet.
Yeah.
So is there such a thing in this area where people agree these are the time series that if you can demonstrate your model works, then people will kind of respect the results?
There is no specific, let's say, community data benchmark like ImageNet, but most of the time, I mean, they compare their results with like a buy and hold models or let's say standard
Index funds.
Yes, index funds,
Yeah.
Whatever they are trying to compete against. So in a lot of papers, though, there is no financial, let's say, evaluation part. It's just the
Oh
model level.
no! Oh no!
Yeah, but I think that's a missing point. But
Yeah. You have to you know, when I was in a hedge fund, you'd have to really model slippage, trading costs,
exactly.
right? So all
Yes.
of these things. Yeah.
Those are. I mean, you can have a good model on paper, but I mean, even if you can forecast good, still you might not achieve the best financial outcome if you apply it on the trading side. So yes, I mean, I think both sides should exist just to show that this is a working model.
So I'm going to put you on the spot. It's something an academic will hate to do, which is basically, if you were stranded, Murat, in a desert island, and you only had one type of neural network architecture to apply to a financial time series, what would be the default that you would use?
Yeah, you put me on a spot. That's right. Well,
so what would be the thing that you would try first? Yeah,
I think the RNN-based models work better. LSTM, for instance, because they are, I mean, already naturally built for sequences. So for time series forecasting, a lot of people prefer that, and I wouldn't argue with that. I mean, I cannot say that that's results. I mean, the LSTM is the probably easiest to apply, but doesn't necessarily mean that that gives the best results. I mean, so it's a trade-off.
So what about so a lot of people also started out with the RNNs and LSTMs, but then they started playing around with convolutional neural nets, right?
Yes.
And so what is so right now there is no consensus as to what to use. I see.
When me and my students, when we checked all the papers, we have seen good models in almost all DL type, I mean, deep learning model type. So it probably depends on how you configure your problem and model together. So LSTM, like I said, it's the easiest to apply because you can just apply your rate of change, like time series data, I mean, without doing anything, and it'll basically predict. And I mean, up to a certain point, I've seen accuracies between 0.54 to 0.65 or some stuff like that, which is acceptable in most cases. But there are other models which, if you work on it hard, you can, I mean, try. You can get better prediction accuracies.
So when you say work on it hard, does that mean you're overfitting?
No. That means you work too hard. It backfire on you. Yeah, it's a difficult thing. Feature engineering is if you are not using LSTM, then your feature processing becomes important. I mean.
By the way, Murat, a year ago, I started playing around with LSTMs for time series, and you know, like I said, I came from. I mean, I've been in machine learning for so long, but I was working on time series predating even machine learning, right? So we were using.
Yes. Yeah.
What's really struck me is, and maybe I was doing something wrong, but it seemed slow, these methods, compared to traditional methods.
That's right. Well, that's another point. I mean, you made a good point over there. If you want to apply these real-time on high frequency data, and if you want to train online, things like that, then that's a big challenge. Because, I mean, most of our studies, we basically did offline training, and then we didn't do any intraday trading. It was only daily close prices. So we were doing swing trading models, like triggering the buy signal and then maybe keeping for a few days or maybe a couple of weeks, a month or so. And then we were trying to teach the system that. So for such a model, you don't need that much speed, or you don't need, I mean, you have all the time in the world at that time because you are offline, doing it offline. But if you don't have that time luxury, then yeah, these are problematic areas. And I think for that, high performance computing comes into picture probably. I mean, we haven't done those things, so I cannot really tell too much about the real world details, but there are a lot of services for like machine learning as a service type of platforms that will give you those access, so people can build their models on such things.
By the way, for our listeners who are not aware, the one thing that the finance sector is not afraid of is spending money on something. If it works, they will spend money. If they need compute, they will find the money to buy that compute. By the way, Murat, in your paper where you had the 13 tables, again, for our listeners who are not aware, so in many ways, each of these 13 tables represents a style of trading or an area of trading.
Yes, an application
like this,
area.
Right? So if you map this to humans actually specialize, right? So bond traders, there's equity traders, right? So there's macro traders and so on and so forth. But now we're in the realm of machines. If you look, obviously there were so many papers involved, but you had 13 tables representing 13 areas. So is there something similar happening when it comes to machines, like certain types of architectures and models work well in this area? Another area, maybe convolutional neural network is better than something else. Is that what's happening?
Yes, that's a very good point. Ben, I can say like this: if you, like you said, I mean, those areas are divided by their specific applications. For example, commodity pricing or index pricing, stock pricing, like forex pricing, vice versa. If you want to actually try to forecast the price, then you are doing the real-time series forecasting thing. So RNN models, RNN LSTM, and their, ensemble models are mostly preferred, and then they are easier to basically configure and then implement. But if you change the problem into like a classification problem, just for example, detecting the trend, or find the buy-sell hold, let's say, classification areas, then you can convert your data into a different way such that you can use multi-layer perceptrons or convolutional neural nets or autoencoders or anything with that matter where you can do the classification with your data. So you can have both ways. You can forecast directly, or you can classify, and then you can. That's why you can use all of those models for classification. CNNs work good. And actually they work real good, I think. And for like the forecasting regression models, the RNNs and LSTM in particular are preferred.
By the way, the other thing you did with your tables is you kind of noted what libraries people are using. So are they using TensorFlow,
yes.
Keras,
yes.
or PyTorch, and so on and so forth.
Yeah.
So, question: should someone, or maybe it already exists, but maybe someone should create a package, a library for financial time series forecasting using deep learning, kind of similar to, I'm not sure if you're familiar with Facebook Profit for business forecasting, something usable for a developer.
Yes.
Where you don't need to configure too much the architecture. You can just point it at your time series. So does a library like this exist?
Well, it might, but I'm not too familiar with such a package, meaning that we were always working with Python, let's say Keras library, and then it had all the tools, and people, since it was the most commonly used, it was most up to date in that sense. We didn't need anything extra. Well, one other thing was for visualization or backtesting or things like this. Maybe if there is something that's
so there's
that has the whole package.
There's an opening for someone who to put together such a thing to make it more accessible, right?
Yes. For sure, people are looking for such things. They're always asking for it. I've seen like many open source libraries, like time series forecasting libraries, but most of them had some aspect of it covered, and then so I'm not sure if I checked that Profit, and then it's it's commonly used also. It's quite
and it's also accessible to a developer who's not an expert.
Yes.
Right. So so someone listeners out there, someone needs to put together a package like this, and
let us know.
Let us know, exactly. So the other thing you did is there were some areas where you started also combining time series and text mining.
Yes.
Right. So, which is actually, for our listeners out there, actually, this is not unheard of in finance. In fact, finance people do this all the time, right? Because they're trying to find signals.
Yes.
And so one of the things that makes financial time series forecasting, especially for trading purposes, is everyone is looking at the same data set. So imagine being in a competition with the whole world, with all the supercomputers in the world, right?
Yes, that's a tough
so people are always looking for signals and data sources, alternative data sources. And in recent years, Murat, that seems to be a lot of it is text-based, right?
Yeah, lately it's show. I mean, it has a lot of interest. Like the NLP tools that are, I mean, for example, something like GPT-3. I mean, the transformer networks.
Right.
I'm sure people will start using those. Well, trying to make the best sense out of it.
Right.
Whatever blog or just news that comes out. I mean, it's an arms race. It's
Right.
just like in the first few milliseconds, whoever gets the content, let's say, the most understandable way, then act accordingly. Then yeah, that's the goal. But text mining, not only for forecasting purposes, I mean, people use it for, let's say, a lot of other things, like those financial reports, analyst reports, things like this. So when the report comes out, it's, let's say, pages and pages. But if you can carefully, I mean, and obviously fast, quickly, I mean, cover it and then make a decision out of it, then obviously you have an advantage over anybody else. So people are working on those things. I mean, the best approach, I think, for the future is to combine that textual data and then make, let's say, a decision from that, and then ensemble it with, I mean, integrate it with, let's say, standard time series data of the numerical data. And then the best models probably will come with combination of those two things, because they are independent. The textual data shows whatever is happening at that time, real time, and then the numerical data shows the history. So you have the best of, let's say, both areas. So that's probably the future of these things.
So you and your collaborators went through the research literature to understand how people are using deep learning for time series forecasting. So a few years ago, I asked a friend to, and I made introductions to people in finance and hedge funds, and say, so why don't you write something for me, interview these people, try to get a sense of what they're using. Are they using deep learning or machine learning? And no one wants to talk on the record, right? So this is the trouble in finance. So
yes, yeah.
So the best I can say is, and this is completely kind of non-scientific, based on my conversations, it seems like people are using machine learning. Some people are using deep learning, but no one has tossed out everything in favor of deep learning. I mean, finance people, Murat, as you know, are extremely pragmatic, right?
Yeah.
So they're not attached to any technique or anything like that. If it's something that works, they add it, but they're not going to abandon everything until they know for sure this is something that they can count on for years and years, right?
Yes, yes. I mean, for sure, if you have build a model that's working real well, I would assume that they wouldn't share it with outside.
I mean, the
Unless,
non-disclosure agreements in finance are insane, right? So,
yes, yes, yes. There, somebody was joking about something like this. Let's say the the financial research people, they basically work on something, and then the models that work, they use it in their hedge funds or like quant funds, and the ones that don't work, they publish it. And probably, I mean, that's a joke, but
yeah. There's some truth to that, probably, right?
well, there might be. I mean, you never know. Yeah.
Yeah. So going back to these areas of the 13 tables that you guys put together. So what are the 2 to 3 areas where you feel there's so much promise?
Application-wise, I think just like you mentioned like a few minutes ago, text mining-based forecasting has some good potentials for the future. Also, I think cryptocurrencies, they are getting more attention. Well, I don't know if it's it's not much different than actual stock price forecasting, but it's more volatile. So, I mean, if you have a good model that can basically detect the
and less
ups and downs.
players, less sophisticated
Yes.
players, right? Yeah.
Yeah. So that's one thing. So for model-wise, I think reinforcement learning has, I think, some good potentials, even though nobody really knows how to apply it the most, let's say, applicable way, because it's difficult to, it's not like a classification or forecasting type of thing.
Yeah, it requires even machine learning people have to get their head around how do I
Yes.
cast my problem into this
Yeah.
RL framework, right? So,
but I think for research-wise, at least, there's good potential in that. People have been working on it for some time.
I actually know some companies using already RL for some trading. Yeah.
I think if you can, like you said, if you can figure out how to model it into your problem, it can do real good. I mean, it has good potentials, but it's not easy. So yeah.
By the way, the other thing for people who are not familiar with finance, the other thing that makes finance a little tricky is so on paper it's structured data, so you have a timestamp and so on and so forth. But things are happening so fast that the first time you go through the data might be, there might be some errors, or
Yep.
you know, I remember in the past having to and I think they still do this. I'm amazed, you know. I mean, I would look at some option prices. I would go, "Oh, this doesn't look right. Let me call Bloomberg." Someone on the other side would answer the phone and fix it. And then you realize, oh, that's because for Bloomberg, the data is the most important thing, right? So they have to develop a good reputation for having good data. But now with high frequency trading, I imagine that's also a particular challenge, right? So the
streaming data.
but these models might be thrown off by if there's some anomalous behavior, right?
That's true. Well, for our case, we have the time to clean the data, and like you said, I mean, most of the time there are some problems with the data, like some missing data or some definitely wrong data in any pricing. I mean, option pricing, the ridiculous bid-ask spreads, like it wouldn't be like that. Or basically, for our case, we try to fix them, like meaning that like standard data, what are you calling, correction sort of techniques.
Right.
But in real time, yeah, it's difficult. It's a big challenge. So
you have to combine some kind of anomaly detection tool.
Yeah.
Up front, right? So, by the way, for our listeners, Murat and his collaborators also wrote another paper called Deep Learning for Financial Applications, a survey. And I will make sure to link to both papers in the notes accompanying this podcast. And there they looked at basically more broadly. So they looked at things like financial text mining, sentiment analysis, portfolio management, fraud detection, and so on. So in that paper, Murat, what areas were you most excited about in terms of after you went through the literature? What areas showed the most promise as far as applications of deep learning?
Okay. First, let me tell you why we had two surveys. Well, our initial intent was to have like one survey that'll cover deep learning for finance. But then we realized half of the papers, almost, or even more than half, was time series forecasting papers, financial time series forecasting papers. And then the number of papers were substantial. I mean, it was adequate to cover one survey. So then we divided into two. So we covered the financial time series in one survey, and then the rest of the applications in the other, and call it financial applications. So in that paper, the most, let's say, I mean, there are, let's say, portfolio management, risk assessment, and especially the financial text mining, sentiment analysis. Those are basically we saw the most interest.
So what's your sense of, so you went through the research literature. So what's your sense of how does the research literature represent how what industry is doing at this point?
I think it matches with, let's say, whatever the industry is looking for. Most of the time, the researchers are also focused on those things.
But are they beginning to use some of these deep learning techniques in industry, in those areas that you covered?
For the algo trading models, I don't. Well,
that's
probably
hard.
They are using.
Yeah, yeah.
I'm not. I mean, I cannot really tell because I don't.
No one talks in that world, right? So yeah. But the financial text mining for sure, right?
Yes, financial text mining. There are a lot of. I mean,
because text and NLP is dominated by deep learning, right?
Yes.
Yeah. And then fraud detection, I would imagine they use it as well, right? Because deep learning has a role in graph data as well, which is important in fraud.
Yep.
Portfolio management, but that's an optimization problem. You might even be able, Murat, to cast that as reinforcement learning.
And most of the reinforcement learning models are actually used on portfolio optimization, like you said, because that fits well into that. I mean, for forecasting, there are some RL, I mean, reinforcement learning models, but most of them are for portfolio management, and also evolutionary computation, genetic algorithms, and stuff like that. That also fits well to portfolio management. And those robo-advisory models, I think they are getting more common. And then, and most of the time, I think this machine, I mean, it has been used for a while, but probably it'll increase because people want more, let's say, diverse and profitable, let's say, portfolios. So one way to achieve that is deep learning models might help. So yeah, I mean, that's one area that can actually.
By the way, I'm looking at the summary of the financial applications paper, and you talk about hybrid models, and actually just I realized earlier I was saying finance people are very pragmatic. They're not going to throw away everything in favor of one method. But actually, that's actually true of everyone in many ways, because I remember at an AI conference that I chaired, Uber presented their time series forecasting models, and they were starting to use deep learning, but they made sure the audience understood, hey, deep learning is part of an ensemble, right? So we're not going to throw out all of the statistical stuff, right? So
yes.
Yeah.
And that makes sense because you have a working model, you have a new model, but why don't you use them together? I mean, to make a more informed decision. I mean, it's only logical, I think.
So actually, let's close by having you talk about your role as chair of artificial intelligence engineering, because actually, so out here, people are starting to have. I mean, so they have computer science degrees. Now some people have data science degrees, right? So programs. So in your case, I noticed that you folks call it artificial intelligence engineering. So how would you describe this program?
It's you can call it as a data science bachelor's program. I mean, in general broad sense, because that's what it is.
Okay.
The term we used, artificial intelligence engineering, is kind of more attractive to people. That's why. Otherwise, it's not. It's combining software engineering and data science together. So our students, once they graduate, they can work as a software engineer if they want. I mean, they are going to have all the background for that.
Great, 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 great. Because
And
a lot of
yeah,
the uh, a lot of data science programs, my criticism is there's too much emphasis on the modeling
yes,
aspect instead of the software engineering and data engineering, which, you know, if you get to the modeling part in industry, you are doing somersaults, man, because that's the funnest part, right?
yeah,
So the hard part is the rest to get to the part where you, oh man, now I can enjoy myself and do modeling. Which, by the way, the tragic thing, Murat, is being done by auto ML.
that's right. I don't know. I mean, our jobs will be gone. Looks like. I mean, eventually at one day.
Yeah,
So
yeah, yeah. I mean, but to have someone who can do the modeling but can also write maintainable, high
yeah,
quality code, right? That can be
yeah.
deployed in production.
That's our motivation. That's our goal.
Yeah.
And also in our program, we opted the students to choose one domain area, so that, for example, our department right now has two areas. One is finance, so computational finance, computational intelligence for financial applications, sort of. I mean, the students are taking, let's say, those derivatives pricing. I mean, some theoretical finance, and then on top of that, computational finance, and then applying, let's say, machine learning into those. So once they graduate, I think they can be fit for some, let's say, quant positions, or some financial, let's say, software development decision support system type of thing. So there is no such program in most of world. So it might help. Also, we have what do you call it? The bioinformatics sort of classes where they can go for health sciences.
Right, 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 right. And you folks also seem to have applications in industrial engineering, smart cities, IoT, right?
Yes, yes, yes.
Yeah.
We haven't set up specific tracks for those, but that's the next step. I mean, we will work on those things.
And with that, thank you, Murat. And I'll make sure to link to the two papers because they are excellent resources.
Thank you,
And
thank you.
thank you so much for writing those papers. And thank you so much for joining us today.
Thanks for having me. I mean, it was great. So, yeah.